So this is part 6 of electrophilic addition to alkenes. And for this part, and actually the next few, we're going to talk about general reactions. So here we're going to look at hydrohalogenation, which is essentially the addition of HX. And when I do any sort of studying, I'd like to keep it as general as possible because it saves you from having to memorize more than necessary. So when I talk about hydrohalogenation, if I'm going to make a flashcard, I would do something like this. This plus HX, where X could equal Cl, Br, or I, would give me this product. Now, in your flashcard, you may have, you know, that missing, and the back of the flashcard would be the product, which would be that. But some things to note on the flashcard as well on either side. I would say on the back, this would be the front side. The back side would be the product and indicating that, this is a carbocation mechanism. This is a Markov-Nikov addition. It is possible to have rearrangement. I get a mixture of syn and anti. Again, so as you start to do these general reaction mechanisms, and again, you could put the name of the reaction, hydrohalogenation. That could have been on the back as well. So that way, when you look at the flashcard and you look at the reaction, you get more familiar with trying to identify what's happening as opposed to memorizing specific reagents because X could have been chlorine. So an example on the back of the flashcard, you could have done more specific then and said HCl is a specific example. But again, by keeping it simple, just putting HX, that saves you from making three flashcards that essentially say the same thing. You don't have to do one for HCl. You don't have to do one for HBr. You don't have to do one for HI. And technically speaking, you could also include, it could be water as well, because H3O plus does the same thing HCl or HBr or anything else does. It's just you're adding water instead of a halogen. You're making an alcohol as a product instead of a halogen. So anyway, as you make your flashcards, keeping them more general is sometimes better because it helps you understand the process instead of trying to memorize every reagent or every starting material. Because I could have drawn something even more complicated, and it doesn't matter what's over here. The key part is this piece here, the alkene. So if I were to add HCl, I would get something like this. It doesn't matter about all of this. It's irrelevant. The only part that's important is the alkene, and I do an anti-Markov-Nikov addition. So if you make your flashcards too specific, you focus too much on trying to memorize reagents and starting materials when there's a million possibilities. If you keep it pretty general, like this down here, we start just to learn about the process. When I see a double bond and I see some form of HX, whether it be HCl, HBr, HI, water, H3O plus essentially. All I'm doing is a carbocation mechanism in which I have Markov-Nikov addition, possibility of rearrangement, so be on the lookout, and I'll get a mixture of syn and anti addition, so I don't have to pay attention to stereochemistry because I get all possibilities. And again, if you want to make an additional flashcard just to be safe, I would do one example in which you have no rearrangement, and then maybe do another example where you do. So your next flashcard might actually be something like this. And then the product would be that instead. So you at least see the example of rearrangement. So there, I just made two flashcards. I made two flashcards showing the general example of a hydrohalogenation, but those two flashcards took the place of about 8 different possible flashcards. I don't need a flashcard with HCl. I don't need one with HBr by itself. I don't need one with HI. I can combine them all into one, and I start to understand the process. It's all about conceptual learning, identifying patterns, pattern recognition, as opposed to memorization. You don't need to get too elaborate with these structures because then you're focusing too much on trying to memorize starting materials. Keep it simple because then when you see a big, like I said, when you see a big example, you know that all of the other stuff over here is irrelevant. We're only focusing on that key double bond piece. So if you want to, in your flashcard as well, you can highlight the double bond. That way you know that you're focusing on the double bond. That's the part that's reacting, not all of the other stuff. All the stuff that I'm highlighting here in red is irrelevant for the most part. Outside of determining Markov-Nikov and anti-Markov-Nikov, the red part is irrelevant. Nothing is adding to that side because that's not the part that reacts with HX. So hopefully that helped for those of you that are trying to develop study techniques. And as we do the next examples, we will see how maybe a flashcard could be written out.